The boundless expanse of space has always captured our imagination, but few companies have transformed our access to it as profoundly as SpaceX. Their achievements, from reusable rockets to launching thousands of satellites, often seem like feats of pure ingenuity. But what if I told you that beneath every spectacular launch and historic landing lies an intricate web of data, meticulously analyzed to unlock cosmic success? We're diving into how data correlation is not just a tool, but a fundamental pillar supporting SpaceX's revolutionary journey. SpaceX didn't just aim for the stars, they redefined the journey. Through groundbreaking innovations like the Falcon 9's autonomous landing capability and the rapid development of Starship, they've disrupted an industry long set in its ways. Their relentless pursuit of efficiency and cost reduction has been unprecedented. But how do they consistently push boundaries and achieve what was once considered impossible? The answer, in large part, lies in their masterful use of data. At its core, data correlation is about understanding the relationship between two or more variables. It's not necessarily about cause and effect, but rather about identifying patterns and trends that move together. For example, if we observe that an increase in SpaceX's launch frequency often coincides with a decrease in the cost per kilogram to orbit, we're seeing a correlation. This foundational concept allows us to make informed decisions and optimize complex systems. For a company like SpaceX, where every component, every launch, and every maneuver is critical, understanding these data connections is paramount. Correlation helps them identify operational efficiencies, refine rocket designs, mitigate risks, and predict outcomes. It's the invisible hand guiding their iterative design process, where each flight provides invaluable data to improve the next, driving their astonishing rate of innovation. Consider the relationship between launch frequency and cost efficiency. One significant correlation SpaceX has leveraged is the more frequently they launch, the lower the operational cost per launch becomes. This isn't just about economies of scale in manufacturing, it's about refining processes, optimizing fuel loads, improving ground operations, and amortizing research and development costs over more missions. Data showing this correlation allows them to confidently pursue higher launch cadences. Perhaps the most visible manifestation of data correlation in SpaceX's success is their reusability program. Each successful Falcon 9 booster landing generates vast amounts of telemetry data. By correlating variables like engine throttle adjustments, grid fin movements, and atmospheric conditions with landing success rates, SpaceX can continuously refine the landing algorithm. This data feedback loop directly correlates with improved booster reliability and faster turnaround times, dramatically reducing launch costs. Take Starlink, SpaceX's ambitious satellite internet constellation. The deployment of thousands of satellites isn't random. There's a direct correlation between the number of operational Starlink satellites in orbit and the expansion of service coverage and subscriber growth. Data on satellite performance, network latency, and ground station bandwidth is continuously correlated to optimize constellation deployment strategies and ensure a high-quality user experience across the globe. Every single SpaceX mission, from engine ignition to payload deployment, generates terabytes of telemetry data. This raw data, encompassing everything from engine thrust and fuel consumption to structural stress and environmental factors, is the lifeblood of their operations. Engineers correlate these granular data points to understand system behaviors, identify anomalies, and fine-tune every aspect of their rockets, ensuring maximum performance and safety. However, correlating data in the unforgiving environment of space exploration presents unique challenges. The sheer volume and velocity of data generated, coupled with the critical, high-stakes nature of each mission, demands sophisticated analytical tools. Filtering out noise, dealing with sensor inaccuracies, and understanding complex interdependencies within unique datasets are constant hurdles that SpaceX's data scientists must overcome. SpaceX isn't just looking at simple correlations, they're pushing into predictive analytics. By leveraging historical launch data, flight telemetry, and component performance, they can move beyond understanding what happened to forecasting what will happen. This allows them to predict potential component failures, optimize fuel burn profiles for future missions, and even estimate ideal launch windows with greater precision, providing a critical competitive edge. As SpaceX sets its sights on even more audacious goals, like establishing a sustainable human presence on Mars, the role of data will only grow. Future missions will generate unprecedented amounts of data from new environments. Expect to see an increased reliance on advanced AI and machine learning algorithms to interpret these complex datasets, driving design decisions for interplanetary spacecraft and supporting the construction of off-world habitats. Ultimately, SpaceX's cosmic success isn't just a triumph of engineering, it's a testament to the power of data science. By meticulously collecting, correlating, and interpreting vast amounts of information, they have systematically de-risked spaceflight, slashed costs, and accelerated humanity's expansion into the cosmos. The next time you witness a Falcon 9 launch or hear about Starship's progress, remember the unseen data connections that are truly propelling our future among the stars.